I'm Karen Hansen. I'm a research developer at Portico, and I've been doing some of the design and development on the RMap project. So I'm here to show you what we've been up to so far. And I should first say that this is a grant-funded project funded by the Sloan Foundation and carried out by Data Conservancy, Portico, and IEEE. So first I want to give a little background. Basically, it's this idea that the scholarly article as a standalone publication is starting to fade quite quickly. So there's a lot of granting institutions now want you to share your data along with the article. Also, some people are sharing code in platforms like GitHub, and a lot of the time these components are all in separate repositories and not all in one place. So on top of that, there's some movement towards recognizing other people who contributed to projects, not necessarily just the authors of an article. And a lot of the time on these projects, there's many roles involved and many people that contributed. So what we're looking at here is quite a broad map of resources, all with different relationships to one another. And many of these things in this diagram wouldn't have a unique identifier like a DOI or an ORCID. So this is the problem that RMap is trying to help solve. Essentially, RMap is aiming to provide a framework that can capture and preserve these maps of connections. So it doesn't try to capture the digital files themselves, but just the map of connections, and it's doing this as linked data. So we're calling these maps RMap discos, and that stands for Distributed Scholarly Compound Object. So a lot of the time these maps don't already exist in one place. So I'm going to show you some examples of discos that we've created in RMap so far that demonstrate how you can combine this data as linked data and get a broader map of one object. So in this case, we're going to show 3 different discos that all relate to one article, the one circled in green. So this first disco I'm going to show you relates to an import from DataCite, and at the middle of this map is a code set that was in DataCite, and it shows you some information about that code, including who created it, some other citations for the code, versions, and also pointing back to the article. So before we look at the actual diagram, I just wanted to show you what's in a disco. So first of all, there's a unique persistent identifier for a disco that can be used to get your disco back later. There's a creator, which in this case was a harvesting tool, but it could be a person. You also define a list of aggregated resources. In this case, we're just defining one code set as an aggregated resource, but you can have multiple objects here, and then they're treated as a compound object. And then what you can do is say as many assertions about those resources as you like. But the one rule is all of the assertions must form a connected graph in the system. So later we'll see examples where you've got more than one resource, and then a list of statements about each of those resources as well. So let's take a look at the visualization. So you can see here that in the middle is the code, that's the orange circle, and it has some 3 creators here. These are the red circles. And then you can also see that there are other identifiers. This is where it points to the article that was circled in the diagram. The code is a supplement of that article. You can also see a link to another version of the code here, and some other website links coming out of this code set. So the second disco related to this article is one that we got from IEEE's database. So in this case, you'll see there's much more metadata specifically about the article, and also some citation information and also the creators of the article itself rather than the code. So in this case, the main aggregated resource is listed as this article DOI. And if we look at the larger visualization, you can see that a lot of this metadata is things like keywords. So I'm just going to switch off those keywords so that we can see what else is here. So you can see that we now have a specific type for the article, which is in the middle, and some other local identifiers from IEEE, and also a citation link here. So the third disco that we have relating to this article is from Protocol, and in this instance we can show that there is a preserved version of the article in Protocol, and we also show what files are preserved by Protocol and what they look like in terms of file type and size. So I'm going to switch to the larger view again. So this time, if we zoom in, you'll see that the article that has been in all of these discos is over here. And there's one thing coming out of this that says this is a format of it. And this is actually a Protocol identifier for a preserved copy of the article. So if we look at this, you can see that there's parts coming out. This has 3 parts preserved, a PDF over here, some XML over here, and over here. And you can also see that it has the status as archived and the location as Protocol. So now that we've got these 3 discos all pointing to the same article, you can see how all of these links start to become a much bigger map that starts to look a little bit like the one we saw in the beginning. So I'll show you what it looks like if we now put the article at the center of the picture. So over here you can see that now we're looking at a resource summary, and the resource is this article DOI. You'll see that there's 5 active discos that describe this resource or mention it. There's a whole list of the statements as text here, but we'll look at the diagram. So now you'll see that this article has a lot of metadata about it. And a lot of it is text-based metadata, things like keywords. You'll see a title over here. So these gray dots don't link out to anything, they're just strings of text. So if I switch those off for a second, you can see that all of these are URIs that connect to this one article. So we have 3 different code sets here, that's the orange circles. We have some creators listed. We also have some citations out here. And you can see that combining these 3 discos creates this much more complex view of the one article. So you can also navigate through and click on these to see more information about each of these objects. So if I go to this one, you can see what we now know about this piece of software, which is it has these 3 creators, some abstract information, it has versions over here and over here, and that it cites that article. So what I've shown you is what happens if you combine 3 discos about one article, and how you can then get this rich data set that you can navigate through visually. Just one thing I wanted to mention at this point, what we've been leaning towards when we put data in here is where people don't have an ID associated with them. So say they have just a name and an institution or something like that. Within the system, we've been assigning them internal identifiers so that at some point we can connect all of these identifiers to a more recognized identifier for people like orchids. So if we go here, you can see that this identifier represents a specific name in our system. So far I've shown you some examples with just one object in the aggregates list. So these examples start to show what happens if you have multiple objects in that list of ORE aggregates. So in this instance, we used some metadata from ACM, and it was for a journal that had algorithms associated with a lot of the articles, and ACM actually has links to those algorithms. So we wanted to show that article with the algorithm as a compound object. And we also took advantage of the metadata that they have to start to experiment more with making these agent names into separate identifiers so that they could be disambiguated later. So you can see it's starting to get a little bit more complicated now, but in the aggregated resources section, you can see we now have an article reference and also this link to a piece of software, an algorithm. So you can see that in the middle is the article, which is a DOI, and that this is linked to a code set, and we can look at that individually as well. You'll see the article here, the type is an algorithm, and it has a title there. So also, I just wanted to show you here how we did the creators. So the creator of the article has been given an identifier, and this identifier is associated with a name and an internal ACM identifier. And also, this person is associated with a role of affiliate. And if we just go over here, help sort this out a little bit. So here we can see this person holds a role that relates to an organization, and this organization has also been given an identifier, and that's connected to some information about that organization. So we can use these to disambiguate better later. So the other example we did was using NCBI PubMed articles, and a lot of articles in PubMed have a link to a specific data bank like Protein Data Bank or GenBank. And so we did this transform that takes an article and all of its related data sets and creates a disco from them. And again, we did some work with the creators and the affiliations. So the example I'm going to show you just has one article and one data set, but a lot of these will have multiple data sets to the article. So again, you can see the aggregated resources have a DOI for an article, and this is actually a DOI for the Protein Data Bank. So if we look at the bigger visualization, you can see that the big purple dot is the article. We have the creator done as an identifier over here. We also have the link to PubMed Central for the article and to PubMed. And there's some citation information here, and that is actually the Protein Data Bank citation, and some different identifiers for that as well. So the final example I want to show you is what happens if you put something like a nucleotide at the center of the graph, and we did this using the NCBI API for nucleotide and linked it to all of the articles that are citing that nucleotide. So this is probably where the visual is a little bit less useful, but you can see that the aggregated resources are listed as this, which is an NCBI nucleotide listing, and all of these DOIs and PubMed references. And then we have the statements about each of those down here, which defines some other identifiers and some basic metadata. Let's see that this disco is just aggregating all of these articles. I'm going to take out that yellow type, which is just saying these are all of type text. So you can see the aggregate, disco aggregate is pointing to all of these articles, and this is a data set that is cited by all of these articles. So one feature I wanted to point out about discos is that you can version discos. So if you need to do some updates to the disco, or there's errors, or you want to add something, then you can just create a new version of the disco. But in our system, unless you delete something specifically because of a privacy reason or some other reason, then that disco will not go away. It will just become inactive. And the purpose of this is so that when you get a unique identifier, you can always get back to that original set of statements that were inferred at the time of that identifier's creation. There's ways in the system that you can move to the latest version if you want the latest version of a disco, but you can always get back to that specific version from that moment in time. So on here you'll see that this disco is marked as active in the top right, but you'll also see that there's some other versions of discos down here. So if we go to those, you can see these ones are inactive. So they're still available, they're just marked as inactive. And you'll see some events here. I'll just show you what one of those looks like. So an event contains the system user that initiated it, a start time and an end time, what was the target of the event, what happened, and what resources were affected by the event. So this is the last piece I wanted to show you. So far, a lot of the work that we've been doing has been around creating an API for this system, and we've been looking so far at the visual representation of the data that's already in there. But this is how you actually get the data in there at the moment. We've developed a REST API for posting your discos, and you basically generate discos according to our model as RDF. We support several flavors of RDF. This is in Turtle, and you would just, there's some authentication that goes with this, but you would post your disco, and immediately you get back an event that generated the disco, and also a link to your new disco. So just to show that that link works immediately, you can retrieve your disco. It will show that it has a status of active. And also in here you can browse to different versions of the disco. In this case we have just the latest version link, but in others you could get the previous version if there is one. And also there's a link to any events that affected this disco here. So just to show you a visual representation of what just happened. You can see this is the disco that we just created, along with an event. So this is just one function of the API. There's a lot of different requests you can do. You can also ask for any resource related triples. So using that code set from earlier, this is actually a URI to the code set that we were looking at, and we're just asking it to get the triples related to that resource. So you can see here that this is what the system knows about that resource in RDF format. So that's all I have for you. I hope this was a useful demonstration. Please feel free to reach out to us, and I look forward to giving you more updates in the future. Thank you.